graphs of absolute value inequalities, domain and its range. Okay. Do you know how to draw this graph? Like how will the graph of y equal to absolute value of x will be?
So I'm just going to make comments.
Yeah, so it's like there was a line y equal to x, and if you take absolute value, it will become absolute value x. Y equal to x graph means, this is important to remember, it's a 45-degree line passing through the origin. 45 degrees, symmetric, exactly in the half. So it's like the entire angle is 90 degrees, right?
Yeah, I was trying to rotate this 45 and this 45.
Yeah, so if you take absolute value of x, whatever it was down, it will come up. This will reflect like this. So this is the graph. Now, okay, this is the basic of them all. Next is domain range. What is domain and what is range? Domain versus range. Let us understand that first. Okay, so domain means possible x values. Okay. Range means corresponding y values, output. This is called input, possible inputs, corresponding outputs. Okay. See, let's say if I consider a random function, let's say f of x is equal to 1 by x minus 2. Can you tell me the domain of this function f?
Okay, so it's like all real numbers.
If you say x is all real numbers, can it be 0x?
Except 2.
What happens if you put 2 then? 0. So this is not defined, right?
Yeah.
So domain is all reals.
How do I say everything except 2?
Except the element 2. Okay.
Okay.
Like this, you have to indicate that symbols. Except the element 2. Not 1, 2 that is. See everything except 2, right? So
Yeah.
like this. So x less than 2 and x greater than 2. Like this. X less than 2, x greater than 2.
And no equal to signs.
Equal to sign is not there.
Obviously.
See, x should be greater than 2, that is fine.
Yeah, this one should be flipped. The last one.
Yeah, these both are same thing also. Same things only.
So yeah, we obviously don't need this.
See, these two things are same. Yeah. So less than 2 and greater than 2, that is fine. Okay, so domain means possible inputs. So in this case, specifically speaking, you cannot put input as 2. So that is some restriction. So corresponding outputs is range. So if you put x is equal to 0, let's say x is equal to 0, what is the y value in this? So negative 1 over 2 is just one of the numbers out of the many in range. Okay. So yeah, that's the fundamental difference between domain and range. Now coming back to the main topic, which is absolute value inequalities. Look at the graph. It is something like this, correct? So looking at this graph, can you tell me what is the domain and what is the range?
Oh, I put it up here.
Hmm?
Yeah, I'm writing up here.
Hmm?
I was just writing here, like at the top. Yeah, scroll up. You'll see.
So what is the domain?
So I was just color coding domain, like everything here, and then range would be 1 and upwards, but nothing in this direction.
Hmm.
And
If I ask you what is the minimum value, minimum of value of f of x, let's say y equal to mod x, absolute value of x.
um,
See, we don't represent set R. Okay, R itself means it doesn't need this brackets.
oh, you know, okay.
R means
Say them.
set of real numbers. R, capital R means set of real numbers. That itself is a set. You cannot put set on a set, right?
Yeah.
No need. So yeah, domain is real numbers because for domain you have to look out for x values, right? So left to right, and for range, bottom to up, vertical direction. So it is starting from here. This is the maximum or minimum value.
Minimum.
Y values you need to check, correct? For range. So range starts from 0. Wait, listening?
Yeah, of course. Range is 0. I'm just trying to edit this now. To put 0 here.
Say erase that. What is this? So it's hard to write every number inside this bracket. It's tedious. So we say y is greater than or equal to 0. It starts from 0. Minimum value.
Yeah.
So y greater than or equal to 0 means minimum value is equal to 0. So range is this. Okay. So range is y greater than or equal to 0. So scroll, come to the next page.
Okay.
For domain in the graph, go from and left to right along x, along horizontal direction. Okay. And for range in graph, Range in graph. We go how?
Vertical.
Vertical. Bottom to top.
Yeah. Well, yeah, bottom first. Right? Actually,
Okay. So small to big value. Left to right means what? Small to big. Bottom to top means small to big. Negative to positive, like that. That's about identifying domain and range. Left, right, top, bottom. Next is various types of inequalities. How do you graph them? It is the same as, let's say, if I write y is equal to absolute value of 2x minus 3. Okay. See, what happens is you draw as if absolute value is not there. Draw as if isn't there. So y is equal to 2x minus 3. It is a straight line. I think you know how to draw this, correct?
yeah.
So the shortcut to draw this line is x-intercept and y-intercept. Okay. 2 points are enough to draw a straight line. Which 2 points?
Well, -3 and -3 is the y-intercept.
So 0 comma negative 3 is
3
the
over
point.
2 is the x-intercept.
3 by 2 comma
0.
0, right? So these 2 points, if you plot it on the graph, 3 by 2 comma 0, 0 comma negative 3, like this. So you draw the graph, straight line means like this, right?
Yeah.
And absolute value y is equal to absolute value of f x means I have to take the reflection along x-axis.
Right. So better
Reflection
for
along
the
x-axis.
line.
See, y became absolute value of y. That means reflection along x-axis. Positive reflection along x-axis. Okay. So whatever it is down, it gets reflected up. Down graph undergoes reflection along x-axis. Do you understand this point so far?
Yeah.
Hmm?
Yeah.
Hmm. Uh, okay, let's talk about absolute value functions a bit more. So let's say we consider that example. Let's say y is equal to, let's say, 9x minus 5 absolute value. The way to draw this graph is you draw as if, can you try to draw it, this graph?
Yeah.
Yeah, that's it, right? So this is the point 5 by 9, correct?
Yeah.
And this will be 5 x and y intercept. Yeah. So anyway, okay, what is the minimum value? How much in this graph? Yeah, how much is the minimum value? If they ask, what is the answer? So it's not 5 by 9.
Wait, no.
Minimum value. Value means indirectly they are asking about y value, okay? Output. Output. Output value.
Oh, okay. So
Minimum
it will always be this one.
output y value. Okay. So minimum y is 0. So minimum means y greater than or equal to 0. Like that. phi greater than equal to 0. Yeah. So therefore range is y. What? What is range? Can you tell me? See, these brackets are not necessary as of now. Okay.
Yeah.
So write in terms of inequalities. Y.
Y will always be greater than 0. When do you know usually when to use these brackets?
See. Um,
Versus the
yeah, equal to. Yeah. In
sharp
this graph,
point?
where is the sharp point? There, right? So this point is called vertex of that. This point is called vertex. Okay. Vertex.
Yeah.
Vertex of absolute value function. So basically vertex. So let's say if the graph is something like this, inverted this time, inverted V. Spot the vertex quick. Okay. That's it. So yeah. See, that is the vertex. See, vertex can be found by, there is a trick to find the vertex coordinates. Vertex coordinates. See, whatever there was inside this absolute value function. Okay. Let's say in the previous case it was 9x minus 5, right?
Yes.
This is the inside part of the absolute value function, correct?
Yeah.
So you have to equate that to 0. Equate that to 0. So to equate that to 0, how much is x? X is 5 by 9. Okay, if you put 5 by 9, y value will be how much?
The Y will be
This is x value, right?
yeah, 5 by 9.
Corresponding y value is how much? Yeah, 0, right? Yeah, so coordinate is 5 by 9 comma 0 is the sharp point, is the vertex. 5 by 9 comma 0. Okay. So this point which you just saw, we have already spotted that as a vertex, right?
Yes.
So that can be obtained by like that. Let's say if the graph is something like y is equal to 9x minus 5 plus 1. Okay. Can you tell me the coordinates of vertex? Vertex. Do you understand the question?
Sure.
Whatever is inside the absolute value, equate that to 0 to find coordinates of vertex. How much is x? 5 by 9, right? Okay. Yeah, so this was 0. So y minus 1 is 0. Y equal to 1. So the coordinates of vertex are what? So the coordinates of vertex are 5 by 9 comma 1. That is how coordinates of vertex can be formed. Okay. So this is about graphs, domain, range. How to draw graph, how to find vertex, what is vertex. Okay, come to the next page. Yeah. So and so questions, simple questions will be something like this. But if you want to make this more complicated, they can add some other inequality also. I mean absolute value also like this. Some other like this. Combination of some two things.
Yeah.
And not sure if it is in the syllabus, but I'll tell you quickly what it is. See, whenever you are trying to draw absolute value graphs, one thing that is important is to spot the vertex coordinates. We just discussed how to spot the coordinates of vertex. How do we do that?
Equating the inside value to 0.
Inside. How many insides are there? There are two different, right? So basically, this graph will be having this graph as a whole will be having two two vertex. Okay, common sense, right? So graph, I'll tell you how it will be on a rough. Instead of like this, it will be something like it will be jumping like this, like this. Shit, not that. Something like this. Okay. So W instead of V, there are now like this two vertices. Okay, let's see how does that play out. So find the two vertices then first. First things first.
Uh, so so V1, V2.
X coordinate of one vertex is 3 by 2. That can be obtained from this. That is fine. But y coordinate of vertex, it's not 0. Can you guess why? See, we are trying to find the coordinates. If x is this much, how much is the y value?
So we have to plug them into both.
If you plug x is equal to 3 by 2 in this function, overall, what happens?
17 over 2.
So when you put x as this 3 by 2, this becomes 17 upon 2. So this is the coordinate of the first vertex. What about the coordinate of second vertex? Yeah. Inside the absolute value, if you put 5 by 9, you get negative 17 upon 9. But the answer will be positive 17 upon 9. So right there. Copy that and get there.
Okay.
Yeah. So these are the vertices.
Yes.
So what happens is uh, we put some alternative signs. Positive, negative, positive. Okay. Okay. See, first things first. Do you understand this? When you plot this critical points on the number line 5 by 9 and 3 by 2, for the extreme right, you start with the positive sign. So both absolute values open up with positive sign. So plus 2x minus 3 plus 9x minus 5 as it is. That gives us 11x minus 8. This is for this region, okay? For x greater than or equal to 3 by 2 region, graph behaves as if it was this line 11x minus 8. So for x in between 5 by 9 to 3 by 2, so 5 by 9 x 3 by 2 like this in between 3 by 2 and 5 by 9. What happens is you have to check the sign. 9x minus 5 is positive number, but 2x minus 3 is negative number. So if 9x minus 5 is positive, so this graph opens up as like this. 2x minus 3 is negative. Absolute value will be opening up as negative sign like this. And then 9x minus 5 is positive. So positive of 9x minus 5. Like that. So the answer is minus 2x plus 3 plus 9x minus 5.
Wait, so how is this one negative?
Minus.
Minus. Okay. So did you get from here? This way?
See, if it is in this region, see 9x minus 5. 9x is greater than or equal to 5, right? From here.
Yeah.
So 9x minus 5 is what?
9x minus 5.
Greater than or equal to or less than or equal to. Like this, right? So it is a positive sign. So therefore, 9x minus 5 opens up with positive. Okay.
Yeah.
Similarly, if you put
Yes.
if you consider this 2x minus 3 will be less than or equal to 0. So that is why it is negative. So minus of this minus 2x minus into minus plus 3. Okay.
Okay.
So 7x.
What about the equal sign though? Like here.
I mean,
Do we
well,
can it be equal? No.
see, equal to we don't care because we only care about positive or negative. The value will be positive or negative. When you put exactly this value, it becomes 0. So whether you put positive of 0 or negative of 0, it doesn't matter.
Right.
It's like,
But then okay, so can you say then do we like have to solve this or no?
no need.
You need? Okay.
You just need to understand whether these things open up with positive sign or negative sign.
Okay.
Absolute values. So that is the thing. So y is equal to 7x minus 2 for what region? 5 by 9 to 3 by 2, right? So and for the last region, which is 5 by 9, less than 5 by 9 region, both are negative. X less than 2x minus 3 and then 9x minus 5. Both are negative. So both are negative means you have to write like this. So y is equal to minus 11x minus 2. So this is the behavior for this region, x less than or equal to 5/9. So when you draw the graph, we have split the domain into three parts: 5/9, 3/2. Here to here, you have to draw the what line? 11x minus 8 line.
Just a question. How do you get -2?
Well, negative into negative is positive 3, right?
Yeah.
Okay, positive 3, positive 5 will be positive 8. Okay, yeah, that will be positive 8. Yeah, good job.
Okay.
So the theory is we have split the domain now into three parts.
Yeah.
5/9 is here. Let's say 3/2 is here. In this region, the graph is acting as if y is equal to 11x minus 8.
Right.
In this region, we just did 11x minus 11x plus 8. Okay. And in this region, it is acting how?
That region it's 7x minus 2.
Y is equal to 7x minus 2. Okay. So you have to draw the lines and then join them. So it will be graph will be something like this. Okay. So the graph will be something like this. So these are the sharp points. Okay. I thought it will be like this, but never mind.
Wait, so okay.
Yeah. So transformation of functions. I think you know how to draw the graph of this function y equal to x square, right?
Yeah.
What happens?
Just input output.
Yes, we usually the method is like this, correct? You put various values of x and we'll check the y values,
Yes.
correct? So 0 for 0, minus 1 for, yeah, 1 for 1, minus 1 for
-1 for
1.
yeah, same thing.
And then 1 for
1 just same thing.
1. Okay, yeah. So you plot the graph and you'll observe that 0 0 1 1, minus 1 also 1. So 2 4. It's like this. So the graph will be a smooth curve, correct?
Yes.
This is the graph of y equal to x square. It is important to remember. Let's say y equal to 2x square. Can you try it using this method?
So 0,
For 0 it is how
0,
much? 0, yeah. For 1?
1, 2, 2, 8.
Okay. 8.
And now yeah.
Can you
Just
draw that this graph here itself in this diagram, in this axis?
sure. So 0, 0, 1, and 2. So basically it just doubles like
Yeah. So y value has been increased.
here. Something like this.
Hmm. Yeah, so it will be like this. So even if you say 3x square, 4x square, means what do they all have in common? They are all passing through origin, right?
Yeah.
So vertex is at origin, correct? So in general, if we say y is equal to ax square is a graph, is a parabola, vertex lies at dash origin. Okay.
Dash, yeah.
So even if you write y is equal to, let's say, point not 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 1 x square, vertex is at origin, right?
Yeah, just
Yeah, yeah,
I'll put your dash back.
yeah.
Like,
Okay.
I just put it.
So for this also vertex is same thing. What was that?
Parabola.
Okay.
Because it's not a straight line, so.
Okay, what? Okay. Even if you write minus 0.2 x square, graph is a parabola with vertex at origin. Okay. So let us try to understand now what happens if you write x square is fine, but what about x minus 1 whole square? Can you draw the graph? Okay, x square graph, I think you know this already. You draw it like this. Can you draw this
Yeah.
one in the same graph, in the same axis? Try to draw it.
Sure. So I'm just going to. I'll move to the right.
Move towards the right. Okay. So if you notice something, this same graph has been moved towards the right. Okay. This blue graph, same blue graph, move towards the right. Same blue graph moved towards right. Horizontally or vertically?
Horizontally.
Move towards right. Horizontally. By how many units?
In just 1 unit.
By 1 unit. So notice something. The initial formula was this, y equal to x square. X has become x minus 1, correct?
Yeah.
So x has become x minus 1. The effect means what happens is when you change x with x minus 1, graph moves along x left or right. Right. Okay. Similarly, let's say if you want to find, let's say this was the original one. Let's say if you want to find the graph of y equal to x square plus 1 or x square minus 1. Okay, first let's do it for plus 1. So graph for y equal to x square is already like this. Try to draw this in the same diagram axis. So it has moved how?
Moved upwards 1.
So if f of x changes to f of x plus 1, moved along y or vertically, correct? Vertically up by 1 units. Okay. So that is the thing. So for y, it is a bit straightforward. Y changes to y plus 1 means up. But x changes to x minus 1 means See this, if x changes to x minus 1,
Where is that?
up, a bit up, scroll up.
Oh, yeah.
If x changes to x minus 1, what was the observation?
X-axis.
Moved left or right?
This way. Since it's being squared.
See, notice the difference. X has changed to x minus 1, right? In the formula, x has changed to x minus 1. Do you understand? The difference between this one and this one is x has changed to x minus 1.
Yeah.
See, if x has been subtracted with 1, usually it will feel like it has gone left by 1 unit. But that's not the case, right? It has moved right by 1 unit.
Right. Yeah.
So x is a bit counterintuitive. Y is a bit straightforward. X means you can remember it like this. Synonyms, antonyms, you write x, right? Opposite meanings. So x is opposite. Okay. Do you understand?
Yeah.
Or not?
Yeah, I think I remember some of this now. Most of it. Like, from Algebra 1. So.
I mean, there is still concepts left.
Like this part.
Yeah. So come to the next page. Okay. Yeah.
Yeah,
Yeah. So in the graph, in the formula, if x changes to x minus 1, moves left or right? Moves right. So even though we are subtracting, it is moving right. What about this?
f of x to f of x plus 1. Okay. So we're just moving, we're adding 1 to y.
So it moves along y direction, okay? Vertically up. Okay? So in general, let's say if x becomes x plus 3, how will the transformation occur?
So x becomes x plus 3, so then we'll move.
What happens?
Moves 3.
3?
Wait, no, not 3.
9. See, why 9?
Wait.
We only care about how x is changing in the formula. See, if you write f of x is equal to, let's say, x cube, but f of g of x x plus 3 cube, then the difference between this one and this one is what? Objectively speaking, what is the difference? What?
Moving 3 this way?
3 units, right? You are saying?
Yes.
That is not right.
Wait.
See, you have to check this. This one. The top one. This. You see this?
Wait. Negative. So then this way.
Left side. Okay. That is the confusion. So even though if you do plus x plus 3, it will feel like it is going to the right. But it is a bit, x is a bit counterintuitive. Okay.
Yeah.
Y is a bit straightforward. Y is straightforward. So moved left by how many units?
3 units.
It doesn't matter if it is only about x cube. See, if there is a random graph, something like this. So let's say if this is f of x, y is equal to f of x. Okay. So f of, let's say g of x is equal to f of x minus 3 will be,
Mine.
okay, plus 3.
Minus then here.
Okay, plus 3 means this exact thing, okay, this exact thing goes horizontally left like this.
Yeah.
Okay, this goes left.
So plus 3.
So this goes, so from here it will go left. Okay, you're seeing this?
Yeah.
So by 3 units, each and every single point undergoes transformation of 3 units. So when this moves, this will be erased at g of x, that is. I think you understand, right?
Yeah.
So let's say if g of x is f of x minus 3, how will the graph will be? Let's say f of x is some random like this. Can you draw the g of x now in this?
Minus 3. Okay.
That changes the color. Can you?
Sure.
Okay, no need. So yeah, what I can do is, so this is g of x, or draw like this.
Okay. What color was it? This one? And
Yeah,
this
simple, right?
one? Blue.
So that is g of x. G of x is equal to f of x minus 3. That is the rough diagram. Okay. So
Yeah.
this is how the transformation is. If for y, if you are subtracting 3, it goes down. Pretty straightforward. But for x, if you are subtracting 3, it goes left or right. Which one? Right. Yeah. So straightforward. For y and x is a bit opposite. So this is about transformations, like translation, horizontal and vertical translation. Now let's talk about dilations. Okay. Remember what are dilations?
Well, just like an increase, like kind of. So something like this becomes like larger or smaller.
Yeah. So basically increasing the size, right? So by what factor are you zooming in, or by what factor are you zooming out is important, right?
Yeah.
Dilation factor we call it, correct? So this is zoom in, this is zoom out. Okay.
Yeah.
So the factor by which we are zooming in or zooming out, whether it is 1x, 2x, or whether it is zooming out 0.5x, That is important, correct? So that is called dilation factor. So in the graph also there is a concept similar to that. So how will that changes? If x changes to 2x, okay? See, listen to this. If x changes to 2x, or for y, I mean this is called horizontal dilation. X value is being multiplied. The number x is being, the variable x is being multiplied by some factor, okay? So horizontally dilate. Can you guess how will be vertically dilation means? Vertically dilated means, so f of x becomes what?
Becomes
Hmm. Twice of f of x, like that. Okay. I mean that's pretty much it. So this is the difference between horizontal and vertical dilation. So next is, okay, we'll see how that plays out. So this is about x changes to 2x. This is about y changes to 2y, like that. So let us understand the factor, dilation factor. Okay. The next category is about dilation factor.
okay.
Factor. See the concept which we learned just now. For x is it is a bit counterintuitive. For y it is a bit straightforward. Dilation also same thing. For dilation, see y becomes 2y means dilation factor. Can you guess how much?
Dilation factor is 2.
Just 2, right? So straightforward is equal to 2. For this, if x becomes 2x, dilation factor, can you guess? Well, it feels like it is 2, but counterintuitively, it is not actually 2. It is division by 2. Instead of multiplication by 2, it is division by 2. Multiplication by 2 is this, division by 2 is this. So whatever the number. So x becomes bx means factor is equal to what? Dilation factor is equal to
Is equal to 1 over b.
1 over b. Okay. Horizontally dilation, that is. X changes to some number into x. So yeah. This is not just valid for quadratics, okay? For absolute value functions in general, transformations of functions. The topic is transformation of function f of x. So not just for quadratics, cubics, fourth power polynomial functions, it is valid. The same concept valid which I taught just now. Okay. So we can discuss more about that in the next class. For now, I will stop the class. Okay.